All right, let's just get right back into this. Um, so we've got those two equations there. I couldn't find out exactly how, but I'm sure I can back trace how to do this one. It's gonna make me relog into all my school stuff, isn't it? Dude, my heart sinks every single time I look at my grade for reading assignments. It's left as a 0.5 out of 2 until she grades it, so it constantly reminds me that it's a 0.5 out of 2, and it's like, that's like, no, wait a second. The half credit is the free give me at the end. She hasn't graded any of it yet. Oh, dude, it's nerve wracking. Okay. Here we go. Okay, 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 okay. What if I do Google this one? I am deathly afraid that I might have to. Come on, I just hit copy and it won't let me hit Control V. Oh, yeah, yeah, yeah. Sometimes it doesn't just show up, so you have to just type in the last sentence instead of the entire problem. The katakana at the end of that? What in the world? Okay, so what do we know? Okay, well we know it won't let me. It wouldn't let me write. Yo, why is this thing messing up? It won't let me backtrace it. Dude, this tablet's been nothing but problems all day. Work, work, work. Huyan! Is the Huion tablet software up now? Okay, it's up now. Oh, there we go. That's what I want to see. Okay. So we know Z equals 4.5D. I think that's all it gives. Yeah, that's all we're told. So 1 over 2 pi epsilon 0 qd over z cubed equals 1 over 2 pi epsilon 0 p over z cubed. If I'm not mistaken, those just cross out. They should, they should. Let me again just start opening up everything I can find about this problem. I want to see how it's done in 100 different ways. Okay. Some people don't actually even try to simplify it at all. Well, I don't know QD. I cannot get everything in terms of D. I can't get P in terms of D. I can't get QD in terms of D. I know I had the teacher go over how to do this. Chapter 22, number 3. I can't just sit here all day flipping through things though. That's it leaves off right here at chapter 22 homework. Gosh dang, that's just where I wanted to find stuff. Oh, I'm losing my mind. Oh, shoot, it could be in one of the... Could be in my bag. Might have left... It's not written here. Nope. Maybe... No. It's chapter 22, number 9, though. Chapter 22, I struggle with. It's number 4. We're working on number 3. I swear she helped me. And now we're on to chapter 3, chapter 23. Chapter 23. Well, I'm gonna move on. Every chapter gets 1. Every chapter gets 1. It sucks that I have to use it on this. So, yeah, again, I'm moving on. Okay, we've got this awesome gem of a question. Okay. Charge. We have arc radius. Goodness me. linear charge density. So we're going to have lambda. Oh boy, I should pull up the doc for this, shouldn't I now? And we're going to have an arc with the theta, and here's going to be, this is going to be r, the radius r equals 3.9, theta equals 45 degrees, centimeter. This is chapter 22. Wonderful. Okay, lambda equals Q over L. And that's for linear charge density. We've got surface charge density, which is Q over A, charge over length. And then volume density, which is, what is it, Q over V? It is. Okay, I will pause this for a second, and I will be right back. All right, I am back. Okay. This is going to be, the length of this is going to be r times pi over 180. Not sure if that's right. Let's see. Yes, I was right, but I want to convert the R into meters. It's gonna be like 0. Oh boy. 0.03. Okay, so now we have L. Charge over L. So let's see. Charge of negative 275 E over 0.03. Boy, 1.6 times 10 to the something. I always forget. 23rd? No. And then -9? Ah, what is it? What is it? 10 to the -19th. Okay, it looks like I'm getting -1.44 times 10 to the -15th. Okay, and now it says charge of a uniformly distributed. Charge is uniformly distributed over one face of a circular disk of radius. So now it's a disk. So now we're looking for area, right? This one's gonna use this one. 2 over A. Now the area of a disk. Pi r squared. So this one's just going to be -275e over pi 1.95. Now it wants it in meters, so maybe 0.0195 squared. Let's see. Looks like I'm getting -3.68 times 10 to the -14. Yep, it's looking good so far. Now let's do C, which is still going to be this equation. But now it's a sphere. So now this one's just going to be -275e over 4 pi 0.0195 squared. And looks like now I'm getting -9.2 times 10 to the -15. Okay, and then charge D. Okay, this one's gonna be this one. -275e, except this one's gonna be 4/3 pi r cubed, right? Volume of a sphere? Yep, totally. Okay, and it looks like now I'm getting -1.42 times 10 to the -12. Let's see if I rounded wrong. Nope, we're all good. All right. Two concentric rings. The radii r and r prime, which is 3.25 r, and we have d, which is 1.95 r. Now we're asked what is the uniformly distributed charges? What must the uniformly distributed charge on the larger ring, the net electric field at point P due to the two rings is to be 0? So, first off, let me just write some things. Number 1, we don't know R. Okay. Number 2, we're asked to find Q, so we have to pick an equation. So let me just start scrubbing through these notes. So I found something to do with the ring here. And I see a circled equation that says E equals, get ready for this, Qx all over 4 pi epsilon 0 x squared plus a squared to the 3/2. Okay, now this x squared is actually d squared plus r prime. I believe it's r or r prime. Well, what we could say now, so it says it wants the net electric field to be 0. So that means E1 plus E2 equals 0. Or in other words, E1 equals E2. So now we've got Qx, that looks almost like an A, Qx all over 4 pi epsilon 0 d squared plus r equals Qx all over 4 pi epsilon 0 d squared plus r prime. Now we've got some things we can say now. We know that d squared is r. What we could say is 1.95r plus r, 1.95r plus r prime. Okay, for starters, and we can also get r prime in terms of r, it turns out. So, actually, we can just add those now, can't we? I don't know, let's try it. 1, well. Instead, what if we pull r out? So now we've got Qx equals Qx all over 4 pi epsilon 0 r 1.95 plus 1. It's going to be 4 pi epsilon 0 r 1.95 plus 3.25. So really, couldn't we just do this? I don't see why not. I don't have enough math to know that I can't do these things. Well, this is number 5. Number 5 in here anywhere. Yes, I do. Ah, this x This exit was D the whole time. What's that do for us? Well, maybe I was right. Because we're going to have a Q1 and a 2 and a 1 and a 2. So we could probably just do this. Now look how cool that looks. Real gangsta. Which means now we have Q1 times, I don't know, let's do this, it's mathematics. 1.95 plus 3.25. Q1 times 5.2 equals 1.95 plus 1 equals Q2. 2.95. Right, you dig? Why? I want to get this in terms of Q. So does this mean they want Q1? Or does this mean they want Q2? I'm going to assume... Oh, snap. Wait. I forgot the 3 halves. They didn't transfer it here. Silly me. This is actually to the 3/2. Very silly mistake. Dang it. I also forgot that this was squared. Boy, that... Well, we don't have to go back too far. Okay. We groovy now? Okay. So if we just do this divided by this, I'm getting ooh, it doesn't look right. Did they want the other way around? Please tell me it looks better the other way around. Oh, it doesn't look good. Oh, it doesn't look good. Where'd I mess up? Something's wrong. Something's really. Oh, it's to the three halves. To the three halves. I know where I messed up. Okay. To the three halves. Goodness me. Okay. Now this is actually going to be Q2 equals. No. Let's make Q1 equals first. Okay. We're getting Q2 equals. But well, that 5 looks horrible. 5.17. I'm not sure if it's supposed to be negative. Yeah, it's supposed to be negative. Boom. I hate when that happens. Where's my mouse? Oh. Gotta scroll in on this side and scroll out on this. Goodness me. Be responsive. Close enough. Okay. Display is so hard to read on sometimes. It's a disk problem. Okay, I think I have the equation. So for a disk, I'm getting E equals, goodness me, surface volume over 2 epsilon 0 over 1 minus z over square root z squared plus r squared with this This being the map, the atlas. So, well, first off, I guess we can start by finding this. Which is going to be the area, or no, charge over area. And we just did the one over disk, which is pi r squared. Charge of 1.81 times 10 to the 6th e over pi times 0.019 squared. Boy, they couldn't have always conversions with these folks. (1.6 times 10 to the negative 19th, I think. I'm getting 0? There ain't no way. How the heck am I getting exactly 0? They did this on purpose. Yeah, because what if I change it very slightly? I still get 0. If I change it drastically, I still get 0. Oh. When I did times 10, I did times 0 to the... I'm getting 2.55 times 10 to the negative 10th. So, that's something. Charge contained within the width? This has nothing to do with a dot somewhere. I'm cheated. All these ones. Talk about, you know. Oh, this is like a particle. So we've got... What does it even mean, width? So this is what I'm getting. We have a center of the ring with a disc. I can probably... Oh my gosh. So if this is an R, right? R value, wouldn't this also be the width? Unless that's an R value and the width is here. It's ambiguous, isn't it? Oh gosh, I'm spending so much time thinking. What's an equation? Let me get to working on this. We can't use this equation that I have. Jeez, I just want to know what equations used. I'm gonna type in this problem. Great, it's only like a 4-minute solve for the WinY tutor. Okay, so then now it's area. He says, let's see. Total charge equals the surface charge density times area. So now I just need to know the area of a ring. So now we know that also A equals pi radius, or big R times little r, so big radius, little radius. So in this instruction, it's going to be here, and here. Well, let's see. 30 Yokel meters is 30 times 10 to the negative 6 meters. And then 0.5 centimeters is 0.0005 meters. No, 0.005 meters. Safe to say that this is the outer and that's the inner, right? That's much, much smaller. So outer radius is going to be 0.005 squared minus outer minus inner. Yeah. 30 times 10 to the negative 6th squared. Oh, wait. He's calling it 2 pi RW. I'm finding it as 2 pi R minus W. Not even that, I'm just finding it pi R. Dang it! Alright, 10-minute break. Hold on. I'll keep the break timer going, but I figured I'd stop this break and I'd share a poem. Um, Devil walks into Linnabaug's on a rainy Nashville night as the lost souls sat and sipped their soup in the yellow neon light. The devil, he looks around and he gets down on his knees and says, "Is there any one among you scum who'll roll these dice with me?" Now, Eddie, or not Eddie, Red, he just looks away and takes another sip of beer. Eddie strums his guitar and pretends not to hear. Vince, he said, "Not me, I'll pass. I had my share of hell." Kept scribbling on a napkin some songs he was sure he'd sell. Ronnie just kept whispering low to the snuff queen, clutched at his sleeve. Somebody coughed and the devil scoffed, and he turned on his heel to leave. "Hang on," said a voice from the back of the room, "before you walk out that door. If it's some action you're looking for, friend, well, I've rolled some dice before." And there stood Billy Markham. He'd been on the scene for years, singing all them raunchy songs that the town wouldn't want to hear. "I know you," said he'd been cut and bled 1,000 times. His eyes were wise and sad. All of his songs were the songs of the street, and all of his luck was bad. "I know you," said Billy Markham, "from many a dark and funky place, but you always spoke in a different voice and you wore a different face. While me, I've gambled at Music Row with hustlers and with whores, and hell, I ain't afraid to roll them devilish dice of yours." "Well, then get down," says the devil, just as if you was gonna pray. "Take these dice in your luckless hands, and I'll tell you how the game is played. You get one roll, and you bet your soul, and if you roll 13, you win, and all the joys of flesh and gold are yours to touch and spend. But if that 13 don't come up, better kiss your ass goodbye, and will your useless bones to God, 'cause your goddamn soul is mine." "Well, 13, says Billy Markham, "hell, I've played in tougher games. I've loved ambitious women, and I've rode on wheelless trains. So give me room, you stinking fiend, and let it all unwind. Ain't nobody rolled a 13 yet, but this just might be the time." Then Billy Markham, he takes a dice, and the dice are as heavy as stones. They should," the devil cried, "'cause they're carved from Jesus' bones." Then Billy Markham, he flips the dice, and the dice they have no spots. "Sorry," says the devil, "they're the only dice I got." "Well, shit," says Billy Markham, I really don't mean to bitch, but I never thought I'd stake my soul on a sucker's game like this." "Well, then walk away," says the devil. "Ain't nobody tying you down." "Walk away where?" says Billy Markham. "This is the only game in town. But I really should say before I make my play that if I should chance to lose, I will this guitar to some would-be star who ain't afraid to sing the honest blues, who ain't afraid to sing the words like damn or shit or fuck, who ain't afraid to put his ass on the stage where he makes his bucks. But if he should play this guitar safe and sing some sugary lies, I'll haunt him till we meet in hell. Now gimme them fucking dice." Then Billy Markham, he shakes the dice and he yells, "Come on, 13." And the dice they roll and come up blank. "You lose," the devil screams. Though I really must say before we go on our way that I sure do like your style. Of all the fools I've played and beat, you're the first that's lost with a smile. "Well, hell," says Billy Markham, those odds weren't too damn bad. 13 years on Music Row, and that's the best damn chance I've had." So Billy Markham and the devil, they walk out of Linnabaugh's door, leaving Billy's beat-up guitar lying there on the floor. And if you go into Linnabaugh's, you can see it there today, hanging from a nail on a wall of peeling gray. Billy Markham's old guitar that nobody dares to play. Alright, break over. Back to this. So A is 2 pi RW, so that means this is going to be 2 pi times 0.005 times 30 times 10 to the negative 6, which is this is 9.42 times 10 to the negative 7. So now we just multiply these two. I'm getting 2.4 times 10 to the negative 16. Does that even seem right? Yeah, that's it. Oh, why does this one have so many? Ah. I do have to be up at 5:30 in the morning, and it's 10:10. I don't know. I might call it right there. I might call it. Whatever. What's that mean? I did like 10 problems in a day. It never feels good. I'll do one more, but it won't be for this. It'll be this. Okay. A picture of the diagram. Okay. Okay. Let's see. Ow. 2.1 millimeter. I bet you it wants it. Does it want this in meters? Yeah. So this is going to be 2.1 times 10 to the negative third. And the answer to this one's going to be negative 240.78. This is going to be times 10 to the third meters per second. And as already stated, this one's times 10 to the negative third meters. Now everything should be in the proper units. Whoops. There we go. And now let's just denote what M is and what Q is. Okay. A equals QE over M, which is going to turn into 1.6 times 10 to the negative 19th. It's going to be times 240. $786. Does that number look right? Nope. Just don't look right to me. I know why. Here we go. This is actually 12. 380. .952, of course. And this whole thing is going to be over m, which we just found is 1.67 times 10 to the negative 27. So then a becomes now kinematics. B squared minus u squared equals 2AD. We know what D is. We got what A is. So 2 times 1.18 times 10 to the 12th times 2.1 times 10 to the negative third all over v, or u squared, where u is speed. And this is going to be 3.9 times 10 to the negative fourth. Jeez. I really hope that one's right. Nope. Ha ha. Never is. It never is. I've not been able to get this problem. Whoa, it's not even close. It's actually not even close. Now what did I do so wrong? Okay, let's think about this one more time. Let's celebrate and dance so free. This is exactly what I put into the calculator. But this should be negative. It turns out. Is that the issue? Nope. Let's just try to split it up. I guess it shouldn't make a difference. It shouldn't make any difference at all. Yeah. Oh my goodness. So I'm somehow getting even worse answers. Oh, I know why. I know why. Hold on. Nope, that's I came to the same answer that I just had. Wait a second. I think I know why. Hmm. So far off. But I think it's doable. Okay, I don't even want to try to write the number I'm getting for this one. But now I know that's supposed to be a positive number. Not quite actually even. That's supposed to be negative. Yeah. And then if I do 3560 times 10 to the third, and I parenthesize that, and of course I get the glitched parenthesis. Yeah, error syntax. I syntaxed it right. You're just a retarded calculator. Okay. And if I take this number and I subtract this negative number here, I take the square root. No, it's just an overly large number again. I want it in kilometers per second. I have it in meters per second. So divide by 1,000. Okay. Okay. Maybe I got somewhere. Wait, whoa. Not even close. What? Actually, what? D is 2.1 times 10 to the... Where? Where could I have possibly gone wrong? To get it that wrong. Legit. Actually legit. What in the world? I'm pretty sure I followed that darn right on. So that looks fine. M and Q are constants. Acceleration. Yeah, it looks fine. And that even looks fine. I used all the right numbers. All the numbers were there. All the way to 54. Boy, how do you get it so wrong? I'll try it this other person's way. It's gonna be the same way. But let's see if anything changes. Zero zero 005. Whatever. Yeah, it's all the same thing. Okay, my E's looking good. Up to this step, we're still looking good. Now it says A equals QE over M, which is gonna be 1.6 times 10 to the negative 19th times 12,380. Gosh dang, right back where we started. Over 1.67 times 10 to the negative 27. But you know what, whatever. This guy says 1.6726 times 10 to the -20. So let's just be completely dead accurate. And then we're getting 1.184 times 10 to the 12th meters per second. V squared equals. They want the speed. It's going to be 3560. I'll keep it. No, I gotta put it in meters per second, don't I? Times 10 to the third meters per second squared. Okay. It's going to be plus 2 times negative 1.184 times 10 to the 12th meters per second multiplied by 2.1 times 10 to the negative third. Okay. Let's just calculate that real quick. We're getting 3560 times 10 to the third squared plus 2 times negative 1.18 e to the 12th meters per second times 2.1 times 10 to the negative third. And then we're going to square root this. And then we're going to divide by 1000. And I'm kidding. Can you guess it? 3559.3. I hate this. How is it 45? How is it 4570? 4670. How is it 4670? Ow! How is it? How is it 4670 kilometers per second? That math just legit, actually legit does not add up. I can't make it add up if I tried. Okay, my calculator is straight up about to die. You see that lag spike too? Goodness me. I found something great, something absolutely fantastic. Okay, we're getting, get ready for this. It's just straight how to get to V. V is the square root. Oh my god. Square root of This is saying 90 times 10 to the third. We're at meters per second. Where are they getting that? Let's find where they're getting that. This is 90 kilometers per second. So if they're 90 times 10 to the third, guess what we are? 3560. Squared plus 2 times 1.6 times 10 to the negative 19th. And then what is this, V1 minus V2? Negative 75 plus 49 over 1.67 times 10 to the negative 27. Gosh dang, this thing is slow as balls. But let's put this into the calculator before the calculator dies, hopefully. You won't believe it. You legitimately will not believe the answer I'm getting. Could you guess that the answer here is 3, 5, 5, 9? Everywhere I go that has any equation on how to do this is giving me the wrong answer. And I'm putting it in exactly how they're telling me. Honestly, how does it not matter if it's 75 plus 49 or 49 plus 75? Oh my gosh, dude, that's freaking me out. V1 minus V2 is V1 plus V2. Negative V. Oh my gosh. It's actually, oh, on my neck. My neck is getting creaked. It pains me. It pains me to know that I'm doing everything right and getting the answer wrong.
Okay. In other words, it's going to this is D. So I got people who want to make them good. Once I have for final speed. The reason why energy is the better way to go, well, one, I think it's a real mess. That's a more simple, maybe a little. But also, this one, you have to have constant acceleration. With this one, you don't. This works for even when you don't get constant acceleration. So, okay. Direction of V square V. तो यहाँ से लिखेंगे तो यहाँ पर टोटल निकल कर आएगा 20 वोल्ट V2 minus 120 वोल्ट निकल कर आएगा. Now let us solve it. तो हम यहाँ से लिख सकते हैं V8 is equal to 9 into power 4 whole square 1.6 plus into 10 power minus 3 into 20 into 2 upon 167 into 10 raised to power minus 27 whole root हो जाएगा. After solving this, you will get the value of Vh, that is the final velocity at the second.
Okay. Let's see what these people are getting. They're saying that V equals the square root of, so they have this same thing here, 3560 times 10 to the third squared. Plus then they have this big thing here, and it's, oh no, there's this minus. Is that the difference? Let me check before I start typing everything in. No, still doesn't matter. That alone is not the difference. And let me guess, they're 20. They got 20 from doing their first two numbers. It's gonna be V1 plus V2 or V2 minus V2. I'm gonna bet. Why is it 6.17 instead of 1.67? Am I dyslexic? No, this is 1.67. Everything's 1.67.
Into 2 upon 1 7 into 10 raised to power minus 27 का whole root हो जाएगा. After solving this, we will get the value of Vh, that is.
I'm actually even gonna check what they put in. Make sure it even works. 9 times 10 to the fourth squared minus 1.6 times 10 to the negative 19th times 20. 20 times 2 over 6.17 times 10 to the negative 27th. It's 80, 8440. No, it's not. Now let's see if I do 1.67. Now I'm getting 653. Yeah, whatevs. So if they're getting that, and I know that, well, let's see, do they do V1 minus V2 or V2 plus? V2 minus V1. Okay, so if I do negative 49 plus 75, that gives me 26. And they have just a 2. They just say 2. Where'd they get that 2 from? 2. Instead of 9 times 10 to the 4th, instead I've got 3560 times 10 to the 3rd. Can you guys guess what I'm getting? Oh my gosh, I'm gonna blow my brains out. I'm gonna actually blow my brains out. Every single place that I go to says that this is how this problem's done, and I'm going to blow my brains out. I'm just gonna, and there's nothing left to say. Let me quickly plug. Plug in the values for this problem. V2 goes on this side. This is going to be V2 is 52, 75. We have 1.9. Funny that never even comes up in this one. What if I add it? No, doesn't mean a thing. I guess it ain't got that swing. Oh boy. Yeah, let's go back to putting this in. This is 52. That's 75. It's 1.61. Those are all constants. And then right here, we've got a 3, 4, 4, 0. I'm getting a I don't know, a 34, 39 kilometers per second. Wrong. It's whatever. It's not solvable. It's just not. So there goes my studying for the day. 11 o'clock. Time to hit the hay.